firecracker production begins with the rolling of thousands of paper tubes. In the past, this operation was done entirely by hand, but now most of the tubes are machine rolled. After cutting the roll of tube paper to the required width, an electric drill motor is used to tighten the layers. Here, the machines will be rolling all red crackers, used domestically by the Chinese for many of their celebrations. Factories employ a number of machines running many hours each day to keep up with the demand for tubes. Since each machine can only roll one size of tube, several differing machines are needed to make tubes of varying diameters. The machines themselves are of a very clever design and can roll tubes from an inexpensive, low-grade paper. Tubes are formed in a continuous process as the paper feeds into the machine. If you watch closely, you will see in slow motion a series of metal mandrels being extended by a cam track into the path of the red paper. A rotating brush applies a small amount of thin glue to the paper. Simultaneously, the paper is being cut and continues to wrap around the mandrel. As the mandrels travel around the central stationary drum of the machine, the paper is rolled completely into a tube. Once the mandrels come around the backside of the machine, they are retracted by the cam followers, and the finished tubes are free to fall off the machine and down a collection chute into a waiting bucket. From the rolling machines, tubes are taken to an adjacent building where they are tied into hexagon bundles. These bundles make it very easy to complete the necessary steps required to transform the tube into a finished firecracker. The bundles also make it simple to keep track of the number of firecrackers being produced, since every bundle contains exactly the same number of tubes. Only bundles need to be counted and multiplied by the number of tubes in the hexagon, in this case 469 tubes, to get an idea of daily production. To speed up the rolling and bundling process, tubes are rolled twice as long as needed, and then cut in half after they have been formed into the hexagon bundles. As you can see, this is a highly skilled job that requires a good eye to get the hexagons to come out nice and flat. Except for the height gauge block used to score the outside tubes, no guide is used to cut down through the remaining bundle. After the tubes have been cut in half, the next step is to close one end of all the tubes in the hexagon. On the small firecrackers seen here, clay is usually used to form a plug. Again, a skilled person is required to get exactly the right amount of clay in each tube. Some tubes receive a paper top which facilitates the filling process of the tubes. Once the glue dries, holes are quickly punched through the paper into each tube. This acts to funnel the powder into the tube during the loading process and prevents powder from trickling down the sides of the tubes, keeping them clean. Larger tubes are still rolled by hand, and in fact it is still cheaper to roll some tubes by hand than to have them machine rolled. The reason is that a human can roll tubes from a cheaper grade of paper, while high-speed automated machines often require a stiffer, more expensive type paper. When workers hand roll a tube, they use a heavy cardboard-like paper glued only on the ends. The paper is wrapped around a steel mandrel and then placed in a simple device to tighten the turns. Depending on their use, some tubes will be closed off by crimping the layers of paper back down inside the tube, instead of sealing the end with clay. Even larger tubes sometimes require the layers to be crimped in with the help of a length of wood used as a small hammer. After one end of the hexagon bundles of firecrackers are closed off and dry, the bundles are carried to a remote section of the factory to be filled with flash powder. The filling operation is done entirely by eye, and a quick flip of the wrist is required to measure out the exact amount of powder in each tube. After the tubes have been filled with flash powder, they are again transported to another section of the factory where paper fuses will be inserted into each tube. While many factories still do the fusing operation entirely by hand, in some factories machines are being used to cut and place 13 pieces of fuse at a time into the many rows making up the hexagon bundles. As you can see, the machine is still not quite perfect. After the fuses have been inserted, a white powder will be shaken in around the fuse of each tube. This powder, which the Chinese call tube closing powder, absorbs moisture from the air, becomes hard, and seals off the tube. On larger crackers, the tubes will be crimped around the fuses to close them off. Most of the smaller crackers destined for export are now bundled together in packs by a simple kind of braiding machine powered by a foot treadle. This is much faster than the traditional hand braiding method still seen in some of the fancier packs. final step in making firecrackers involves wrapping them in the familiar red glassine paper and attaching a brightly colored label. Afterwards, the single packs are bundled together with a cellophane wrap, and the bricks of firecrackers are ready for sale. Close by the Firecracker factory is a factory devoted only to making various types of fuse for fireworks. This factory can manufacture paper firecracker fuse, visco safety fuse, black match, and quick match. This factory makes its own black powder, which is the basis for all the different types of fuse it produces. The messy process of mixing black powder starts in this building. A hot, saturated solution of potassium nitrate is prepared, into which is mixed finely ground charcoal. The mixture is stirred and then allowed to cool on a concrete slab floor. Later, sulfur is introduced, and the mixture is placed in a mill for incorporation and grinding. 4 brass wheels rotate in a large wooden V-shaped trough for several hours until the powder has attained the desired qualities of strength and fineness. The mill is beautifully constructed out of wood with lantern-style gear teeth and a heavy wooden shaft powered by an electric motor located in an adjoining room. After grinding, the powder is spread out in a thin layer on concrete slabs for drying in the sun. Paper firecracker fuse is needed in huge amounts to supply the numerous firecracker factories in the area. Ingenious machines have been developed to provide this fuse in continuous lengths. The fuse is very high quality and is remarkably consistent in size and burn rate.
整边是这些实在不好做的这题。 你要只用这边上一次用是吧？不要搞毛的了。
中啊。
中你中哦。
中，功不成责，就没什么带领的。
不要成高脚的搞晓得吧？
啊，不要成高脚的吧？
哦，中是等于是把布得散开来。
The machine consists of two sections, the filling section and the twisting spooling section.
大一点就冲过来。
哎，你冲我这师傅晓得吧？
好，可能有没有？我好像该给到这个。
啊，你不晓得搞的。
对呀。
The filling section works by carefully dispensing a thin line of black powder from the green reservoir onto a strip of flat white paper. Overflow from the filling process is caught, and two red conveyor belts transport the black powder back up to the top of the green reservoir. After the paper strip receives the thin trail of black powder, the strip is fed through an orifice which starts the roll of flat paper into a tube. The spooling section of the machine continues the twisting process as the fuse is wound on a spindle. The paper fuse after filling is run as a pair of strands through a bath of rice glue to prevent the fuse from untwisting and to make the fuse slightly stiff for easier handling. A long lead screw turned by a worker makes running the fuse onto a drying frame fast and easy.
也是松烟，也是三个烟，也是四线，也你点一个，你反正卡不需要了，这就是了。这个，我的意思是这干个要同意，他同意要因还一种的70万嘛，70万，还一种的70万。
哎，你做好了，啊，真是多。
也给晒干了要，不晒的。
不要晒不得，晒的要给人造也。
啊，是碰到那里个呀，有热情的。
晒的是变高的，人可以。
An alternate, more expensive glue bath utilizes a polyvinyl acetate type glue. Here the fuse is run through as single strands, and this fuse will be used for making firecrackers.
啊，搞到送的，等他命用过就是意思，他命高了就送的。你这东西就要按要手法，没得手法呗。那老人已经治，交个书来打一针。
With this method, the fuse is dried on long frames placed outdoors in the sun. Depending on its use, the fuse may be bundled together and cut in shorter length and stored in cardboard boxes, or it may be rolled back onto spools. Quick Match is another product manufactured at this factory. The quick match produced is flat in appearance and consists of 5 separate cotton strings impregnated with black powder and encased in a paper sleeve. The coating of the string with black powder and the forming of the paper sleeve is done in a single continuous operation, as seen here. The process starts with 5 soft, untwisted cotton strings being run through a slurry of black powder. The slurry is constantly agitated by a worker to keep the black powder from settling out of the mix, thus ensuring a thick, even coat of powder on the string. After passing through the slurry, the strings travel out and back the length of the long, narrow room. This allows the powder to dry slightly before the string is encased in its paper sleeve. The quick match sleeve is formed from 2 paper strips as they are folded by metal guide brackets around the strings. A small amount of glue dispensed from a bag suspended nearby is applied to one edge of the top paper strip. The glue will hold the folded paper together as it is flattened and creased before being wound up on a large reel. A few pieces of tape hold the finished quick match reels together, after which they are placed outside in the sun to dry. Safety fuse, or visco fuse, is used primarily for fusing nearly all the consumer fireworks manufactured in China. Thin cotton strings are spun around a central core of black powder to produce this fuse, which burns at a very consistent and even rate. The fuse spinning machines require a large number of small bobbins or spools of string to operate. As seen here, these bobbins are first filled with the string on special high-speed winding machines. Here the bobbins have been mounted on the visco spinning machine and can be seen whirling around the black powder feed funnel. The strings are guided over a metal block and spun around the powder as it trickles out of the funnel. Two additional strings are threaded through the funnel itself to keep the powder flowing evenly. After the first platen of bobbins, the partially woven fuse makes a right angle bend and is led through another set of string bobbins, which put on a second layer of strings wound in the opposite direction. At this particular factory, a layer of thin paper is also introduced between the two string wraps and can be seen coming into the machine near the bottom of the screen. Also notice the drive shaft for the machine going through the wall. A take-up reel completes the spinning portion of the fuse-making operation, and at this point the fuse does not have its coating of colored nitrocellulose lacquer. Here is a double visco machine driven off one motor, again located behind the back wall for safety. Notice the thin strips of paper being fed into the machine on the left and the right-hand sides. After the fuse has been spun, the white uncoated reel of fuse is mounted on a coating machine. 2 coats of green lacquer are applied as the fuse is run through a small orifice in the bottom of the twin coating tanks. Looking at the coating machine from another angle, it can be seen how the fuse is run back and forth a number of times to dry the fuse on a warm sunny day. Bamboo is used for a huge number of products in China. In the process of raw bamboo into thin sticks, such as those used for fireworks rockets, is shown in a small factory. First, the stalks are cut to the approximate length needed using a large chop saw. The nodes of the bamboo are cut out of the piece in order to make splitting the bamboo easier and to ensure straighter. Next, workers use a special multi-bladed cutter to split the piece of bamboo lengthwise into several sections, each about an inch wide. After splitting lengthwise, the pieces are fed through a machine which removes the weak inner layer of each strip. splitting machines, the strips will be passed through a shaper which cuts the strip into 5 or 6 narrow splints. Since this is actually a cutting process rather than a splitting process, large amounts of bamboo sawdust are generated. As the splints exit the machine, a worker combs the pieces over a sawhorse equipped with rows of nails that help to remove small splinters and excess material. Since the bamboo is worked green, the finished pieces must be dried outside in the sun. Notice the interesting way in which the bundles are fanned out on the pavement for drying.